friends, welcome to our channel. So in today's session, let us have a look on one more network security concept, that is a block cipher modes of operations. So as we know, the encryption process can be done in two ways. One is the procedure, one is the stream cipher, and another one is a block ciphers. So coming to this stream cipher, so we will consider the plain text bit, and each bit will be converted to the ciphertext. So each bit of plain text will be converted to the ciphertext. So bit by bit conversion of plain text to ciphertext, we call it as an stream ciphers. And here coming to this block cipher, the name itself indicates we will collect or we will group some plain text bits and we will form a block, and at a time each block will be processed. So we have seen these in the introduction classes, so difference between the stream cipher and block cipher. And the block cipher, so we are processing each block. So for each block we will get the corresponding ciphertext. So whatever the length of block cipher we are considering, the same length of the ciphertext will be generated. So the complete plain text will be divided into different blocks. Here, so the block size, what is the block size? And here the block size depends upon the algorithm which we are going to use. So there are different algorithms. So for different algorithms there are different block size. So that depends upon the algorithm. So how many ways this block cipher can be converted into ciphertext? So there are different modes to process the plain text to ciphertext. So the first one is the ECB, which stands for Electronic Codebook. Electronic Codebook. The second one, CBC, so which stands for Cipher Block Chaining. Third one is OFB, which is Output Feedback Mode. Next, CFB, which stands for Cipher Feedback Mode. And the last one is Counter Mode. So these are all the 5 different modes we can convert this block of plain text to the ciphertext. So here let us see one by one. So we will see the encryption process, and the decryption process is quite opposite to the encryption process. So we will see the encryption process of all these 5 block cipher modes of operations. First, consider this ECB, which is Electronic Codebook Mode. That is a normal thing. This is a normal mode of operation which we will follow in general. So here just we will consider the plain text. We will consider the plain text. Apply the encryption algorithm. We will get the ciphertext. So in the encryption algorithm we will apply the secret, right? So this is for first block, and the second block similar. So we will get the ciphertext. Let we call it as a C1, right? Here we call it plain text as P1. Again, plain text, which we call plain text 2, P2, which is a second block. Again, apply to the encryption algorithm, by using some secret key, the same secret key, right? And then we will get the ciphertext. This is the ciphertext of second block, which we call it as C2. This process will continue until the plain text block Pn, and we will get the ciphertext block Cn. The same process will be continued. So in every block we are going to use the same key, right? So the plain text. So for example, if the plain text is 128, the plain text length is 128. So here the block size is 64. So this 128 can be processed in two different blocks. So first 64 in block 1, second 64 is in block 2. This we call it as P1, this we call it as P2 in this diagram. And here we will get the C1, here we will get the C2. So by combining this, we can get the final ciphertext of 128-bit plain text block. Hope you understood. So the reverse process is same. By taking the ciphertext as input, apply the decryption algorithm, use the same key so that we will get the plain text. So this is called the electronic codebook mode. It's a normal process which we are following for major algorithms, right? Next, moving on to the second mode of operation, that is electronic codebook mode. Sorry. This we have seen. Cipher block chaining mode. Cipher block chaining mode. So as the name itself indicates, the ciphertext of first block will be given as input for the second block. That means we have to use the ciphertext of first block in the second block processor. So that means we will just apply the XOR operation for the ciphertext coming from the first block and the plain text which we are giving input for the second block. See, consider the plain text 1, apply the encryption algorithm, right? So apply the encryption algorithm, we will get the C1. Here P1 is the plain text, C1 is the ciphertext. Now send this here, XOR with P2, and again apply the encryption. So here we will apply the key. Here also we have to apply the key, and we will get C2, right? So this C2 will again XOR with the plain text of third block P3, and again apply the encryption. Use the key, we will get the C3. This process will be continued till the last block is appeared. Right. So here, as the name itself indicates, cipher block chaining. That means the ciphertext we are getting from the first block is XORed with the plain text of the second block, and then we are applying the encryption algorithm. So here in the first block we are not applying the XOR operation. So here we are not having the ciphertext of the previous block as it is the first block. So here we have to XOR the initialization vector. That means we have to take some values as initialization vectors and apply this for the plain text block 1. So first we have to consider some IV. IV means initialization vectors. So consider some values, and those values should be XORed with the plain text, and then we will get the ciphertext. From the second block, we have to XOR the previous block ciphertext to the present block plain text. So this should be happened. So for the first block, as it is a first block, there is no ciphertext of the previous block. We have to apply the initialization vector. So here the constraint of XOR operation is both the plain text and ciphertext should be of same length. So here if the plain text length is a 64 bit, automatically we will get the ciphertext as 64. So we can perform the XOR operation between these plain text and ciphertext. Here the initialization vector is also should be taken as 64 bit, as we are applying the XOR operation with the plain text, as the plain text is of length 64. For example, if it is a 64, IV should be taken as a 64 bit. If it is 32, IV should be taken as a 32. So this is the initialization vector, right? So this is here also we have to apply the same key for all the blocks, right? So block 1, block 2, block 3, block 4. So for complete plain text, so this is the complete plain text, we will get the ciphertext C1 plus C2 plus C3 and so on Cn. Right? So we have to add them. Next, moving on to the third mode of operation. That is output feedback mode or a cipher feedback mode, anything we can consider. So both are similar, right? The working is similar for both output feedback mode and the cipher feedback mode. So here we will process S bits at a time. S bits. So in general, S can be considered as 8. So we can consider any number. Initially, we can consider S as 8. So at a time, only 8 bits will be processed. So for this, we have to consider 64 bits. Initially, we have to consider 64 bits. From this 64, we have to consider only 8 bits. Right? So we have to consider only 8 bits. Now, let us see the process. First, consider the 64 bits. Consider the 64 bits and divide that 64 to B minus S. So, or we can consider it as a 6. 64 minus S. 64 bits minus S and S bits. So we should consider only S bits, right? This 64 again use the initialization vector. Here the length of this initialization vector is 64 bits. So consider the 64 bits. So divide it into two parts. One is 64 minus S and another one is S bits. And now consider only the S bits, right? So encrypt, apply the encryption. So here we will use some K value. So here also we will apply the 64 bits. And again automatically from this we will again get the 64 bit output. So here we have to select S bits, select only S bits after encryption, right? After encryption, select only S bits and discard the remaining 64 minus S bits. Just a discard. Now, consider this S bits. Apply the XOR operation with the plain text block P1. So here we are considering only S bits and we are applying the XOR operation. So the plain text must also be S bits, right? So that we will get the ciphertext 1. Hope you understood this operation. So consider the 64 bit. So initialize the 64 bits, shift the 64 bits so that the S bits, consider the S bits, divide this into two parts, one is 64 minus S and S bits, and apply the encryption by using some key. We will, from after getting the result of encryption, consider only selected S bits and discard the remaining 64 minus S bits, and these S bits will be XOR with the plain text block. Here the plain text block is also a length of S bits, so that we will get the ciphertext. So this is the ciphertext we are getting, right? So as the name itself indicates, output feedback mode. So we have to consider the output after completion of encryption, not the after completion of XOR operation. After completion of encryption, consider this S bits and consider the same 64 bits. Consider the same 64 bits. Shift the bits so that the 64 minus S, and apply these S bits to this 64 minus S. Yes, bits. Hope you understood. So initially we are not having the previous S bits, so we are considering total 64 bits and we are applying the encryption function and we are selecting only S bits and discarding the 64 minus S bits. So this selected S bits will directly given as a chain to the second process, I mean the processing of second block. So here also we have to consider the 64 bits, apply the shift operation so that the length will be equal to 64 minus S bits, and apply these S bits to this 64 minus S so that the total length will be 64. Now this 64 bits will be given as input to the encryption. Apply the encryption algorithm, use the key, so that again we will get the 64 bits. Again the same, select S bits and discard 64 minus S bits, right? So select these S bits, XOR operation with the plain text P2, here it says S bits, so that we will get the ciphertext C2, and the same process will be applied for a number of blocks. So if our algorithm or if our plain text is divided into 3 blocks, 3 times we have to repeat this. So as the name itself indicates, output feedback. The output from the encryption algorithm will be given as a chain or as a feedback to the next block. So we are adding here S bits and considering the same. So hope you understood this output feedback mode. Next, simple. Next one is cipher feedback mode. Cipher feedback mode. The explanation is same. Here also we have to consider the 64 bits, then divide them into 64 minus and S, encrypt by using the K, along with the key K, and select the S bits and discard the 64 minus S bits, and for that selected S bits, apply the XOR operation with the plain text block S bits. Now we have to give a chaining, not the output, but we have to give the ciphertext as feedback, as input to the next block. So previously we are giving the output, that means output from the encryption algorithm, but here we are in this mode we are giving the cipher feedback. That means we have to consider the ciphertext and we have to add that ciphertext to the second block. So here plain text is S bits, the ciphertext is also S bits. So the same S bits will be added here. Again the ciphertext 2 will be again added to the third block. Similarly fourth block, and similarly fifth block. So like this mode of operation will be performed. So hope you understood. So for these two, cipher feedback and the output feedback, the decryption process is also just a reverse process, but at the time of decryption also we will use the encryption algorithm itself. So there is no, we should not use the decryption algorithm, we have to use only encryption algorithm itself. Right? So encryption algorithm and decryption algorithm, the change is, the key usage is somewhat different. So if we apply a number of keys from 1 to 10 in the encryption, in the decryption, as it is a reverse process, we have to apply from 10 to 1. So for the first block we have to apply the 10th key, and the second block we have to apply the 9th key. So in these two modes of operation, that means output feedback mode and the cipher feedback mode, so we have to apply only the encryption algorithm for both the encryption and decryption process. Right? Hope you understood this output feedback and the cipher feedback. So we will move on to the last one, that is counter feedback. Counter mode, sorry. Counter mode. So we will consider, it's a counter mode, the last one. Consider a counter value, so which is the length equal to the plain text block. So here the length of the counter and also the plain text block must be same, because we have to apply the XOR operation. So consider the counter and encrypt this counter. So here we will use the key automatically, and the output will be XORed with plain text, so that we will get ciphertext C1. Right? Consider the counter length and the plain text length must be same. So that means we have to consider the counter value which is equal to the length of the plain text block. So encrypt this counter value by using some key and XOR with the plain text block, so that we will get the ciphertext. So here there is no chaining or a feedback. So second block, just increment this counter. For the second block, processing of the second block, just increment this counter by 1. So counter value is incremented by 1, and apply the same encrypt, apply the k value, XOR with the plain text 2, so that we will get the ciphertext 2. This process will be continued until the last block, that is counter plus n minus 1, if n blocks are there. Apply the encryption. So the output will be XORed with the plain text block at Pn, so that we will get the ciphertext Cn. So this is a simple thing. And here also, in the decryption process, we have to apply the encryption algorithm. So first two modes, the electronic codebook mode and the block cipher chaining mode, we have to apply the decryption algorithm at the decryption process. And rest of the three modes, that is output feedback or cipher feedback or a counter mode, in the decryption process also we have to apply the encryption algorithm. So I hope you understood these block cipher modes of operations. So very simple and very important concepts. So these, like this, we have to perform the modes of operations. So hope you understood this simple concept, and if you really understood my videos, like my videos and share my videos with your friends. And if you are having any doubts regarding this network security, post your doubts in the comment section so that I will definitely try to clarify all your doubts. And don't forget to subscribe to our channel. Thanks for watching. Thank you very much.